everyone. In order for a power system to be stable, it is important that the power generation and power consumption are in balance at all times. In this lecture, we will focus on the demand side by looking at the different kinds of loads. An electrical load is a component or part of a circuit that consumes electric power. Electricity can be converted into many other energy forms. For example, it can be transformed into energy forms that can be directly used by the consumers, like light, heat, and mechanical energy. A load curve or load profile shows the variation in the electrical load or demand. This variation is shown for a specific time frame, for example, a day. This information is relevant for the generation companies and system operators, as the generation output of the controllable generation units will depend on the forecasted and actual demand. A power balance between generation and demand should be kept at all times to keep the system stable. Let's have a look at some important types of loads. One of the main loads is lighting. Major changes have occurred during the past years in order to make lamps more efficient. The incandescent lamp has a relatively low efficiency and has been replaced by fluorescent lamps and LED lights during the past years. Let's focus on the different types of lamps for a moment. The incandescent lamp is the oldest type of lamp. It consists of a thin filament that conducts electricity. When switched on, the current heats the thin filament and radiates light. To prevent oxidation, the filament is inside a glass bulb filled with an inert gas. This load is a purely resistive load. Therefore, it only consumes active power. The halogen lamp follows the incandescent lamp. The housing of the halogen lamp is filled with a halogen gas. The halogen gas reacts with the evaporated metal and redeposits it on the filament as a self-repair mechanism. The filament temperature can be higher than in the case of an incandescent lamp, and this results in higher luminosity. The fluorescent lamp came afterwards, and it is the main source of lighting today. In this case, electrons collide with mercury ions, resulting in an ultraviolet radiation. A ballast, which is an inductor, is required to limit the current flow. One drawback of fluorescent lamps is that they consume considerable amounts of reactive power, as opposed to incandescent lamps, which only consume active power. The light-emitting diode, LED, or LED, is a semiconductor that emits light when current passes through it. LED lamps have a low energy consumption and long lifetime. The main drawback of LED lamps is their effect on the power quality, as they produce distortion in the AC waveform. Now that we have covered some important light loads, let's have a look at the heat loads. In a heat load, electricity is mostly converted directly into heat by a resistor. Some examples are a boiler, the water cooker, the electric stove, and the aluminum and steel furnaces. When the load is fully resistive, it does not consume reactive power. Mechanical loads have an important participation in the demand curve. The conversion from electrical energy to mechanical energy is done by motors. The first motors that were developed were operating with direct current. Some examples of direct current motors are electric trains and hard disk drives in computers. Nowadays, there are many motors operating in alternating current. Motors are inductive components, and as a consequence, they consume reactive power. Loads can be classified into residential, commercial, and industrial loads. Residential loads are connected to the distribution system. The common voltage ratings of distribution systems are 7.2, 10, 11, and 12 kilovolts. Distribution transformers are used to bring the power down to lower levels, for example, from 10 kilovolts to 400 volts. Residential loads are, in general, single-phase loads. In the figure, you can see three phases denoted as A, B, and C. In order to keep the three-phase distribution system as balanced as possible, houses are connected to different phases. Please notice, for example, that the house on top left is connected between phase A and the neutral, whereas the house on the top right is connected between phase B and the neutral. Commercial and industrial loads are generally connected at the distribution level, ranging from 10 to 72.5 kilovolts, or at subtransmission level, ranging from 110 to 150 kilovolts. In many cases, the public utility brings underground cables and overhead lines to the premises of the company. The company generally owns the medium and the low voltage transformers required to bring the levels to the ones required by the loads. Some large industries not only consume electricity but also produce electricity. For example, by means of large combined heat and power units. With the adoption of distributed generation, residential consumers are now turning into prosumers, or in other words, consumers that also produce electricity. In the coming years, larger loads are going to be connected to the distribution level, for example, electric vehicles. Batteries of different sizes will also play a bigger role in distribution systems. In order to keep the power balance of the system, the future loads will most likely be involved in mechanisms such as demand response. With such a mechanism, the loads will react to incentives and allow a shift in their operation according to the needs of the power system. For example, the time of the use of a washing machine can be shifted so that it matches the time period in which there is a higher production of electricity, like for example, when the sun is shining. Today you learned about different kinds of loads. You also learned about some changes that will occur in the power systems with respect to loads. Namely, some loads will become bidirectional, some large loads will be connected to the distribution system, and some loads will become controllable and participate in demand response mechanisms. Would you allow an external party to control when to switch on your devices at home?